Hey, BCers, Mr. Ellinger here, and I thought one more example. Like I think one more example would have cemented things a little better, and so I thought, I'll do one more example for you, and I'll send the video. If you understand everything, then great. This video is not going to add anything new; it's just going to cement the ideas we had. So we're going to do the third degree Taylor polynomial for sine x expanded around c is equal to pi over 3. And so the idea is that we're taking sine x. So you think of sine x, and sine looks like this. There we go, pen. And let's see, that's pi over 2. So pi over 3 is about here. And so we're taking this point here, and we're making a polynomial function that's third degree that will approximate this curve as closely as possible around pi over 3, around that one spot. And the idea, and we know that eventually, as it goes further off, it's going to wander off into the unknown. But close into pi over 3, we could make a cubic function because they asked us to make a cubic, so that's what we're going to do. Weird erasing going on. And so we're going to make a cubic function that fits the curve pretty well. And this is just showing how we can take a regular curve and create this polynomial curve that fits it very closely. And polynomials are just simpler in a lot of ways, with a lot of facets to them being simpler. And we're going to see more stuff as we go on over these next few days. Although I will say that these sections tend to be more abstract and less practical. But you got to do it, guys. You signed up for the class. Tough luck. Okay. No, I mean, yeah, it's abstract. This is what the class is right now. So Calc 3 is not which is what we're kind of doing right now, is not the most practical of stuff. All right, how do we do it? We use the Taylor formula. So remember that the Taylor series formula for Tn c of x. And so this is just the number of terms that we're going to do, and c is the center of the expansion. And so the formula for it, for some polynomial f of x, is that it's going to be f of c plus f prime of c times x minus c to the 1 plus, and just because I'm running low of terms here, I'm just going to skip straight to the general term here. Normally I'd write an extra one. And the general term is it's fn, the nth derivative of f, evaluated at c over n factorial times x minus c to the n. Okay? So in this case, what we're going to do is our function is sine x. And so we're going to need the sine of pi over 3 and the derivative of pi over 3 and the second derivative of pi over 3 and the third derivative of pi over 3. So let's get it set up. So f of x, or y, equals sine of x. And so f prime of x is cosine x, and f double prime is negative sine, and f triple prime is equals negative cosine. Okay. And now we want to have all of these match up at pi over 3. So we need to know, well, what is the value of this thing at pi over 3? So now we're doing at pi over 3. So sine of pi over 3, that's root 3 over 2. These are where those trig values come in handy, right? Cosine of pi over 3, that's 1/2. Second derivative would, pi over 3 is negative root 3 over 2. And negative cosine there would be negative 1/2. Cool. So this function is equal to f of c. So f of this, so root 3 over 2. F of pi over 3. C is pi over 3 in this case. Maybe I should write that. T, so this is t3 comma pi over 3 of x. Okay. So it's root 3 over 2 plus, and then f prime, so that's 1/2, so it's 1/2 times x minus pi over 3. So if we stop there, we would have a line that goes through 1/2 right there, and that is a slope of pi over 3, which is apparently about what the slope is, or it is exactly what the slope is. 1/2 is the slope right at x equals pi over 3. I don't know if I said that right. Okay, next one, plus, so it's negative root 3 over 2. That's plus negative root 3 over 2 over 2 factorial times x minus pi over 3 squared. And then plus, and then the last one, negative 1/2 over 3 factorial x minus pi over 3 to the third. Okay. That's it, just cranking out the formula. So giving you some advanced warning for tonight. So for tonight, something that you are going to run into is you're going to run into a few tougher derivatives. I remember there's some that involve a little chain rule action. There's some that involve a little product rule. There might be one that does involve quotient rule. I don't think so off the top of my head. I think you can do it by doing something to a power instead, like instead of like, I think it's like 1 over x plus 1 maybe. And so you can just turn that to x plus 1 to the negative 1 and use chain rule instead. So otherwise it should be, so I thought a little bit of derivative practice seems like a good idea, but, and so they'll be a little harder than these ones, but not awful. And you only have 6 problems to do. What do you want? Okay. Sorry. And, I'm just going to simplify it a little bit. So 1/2 x minus pi over 3. How am I doing on time? Doing great. And then plus, so that's negative root 3 over 2 over 2. So that's negative root 3 over 4 times x minus pi over 3 squared plus, and so negative 1/2 divided by 6, 3 factorial 6, so negative 1/12, and x minus pi over 3 to the third. And if you graph this function here, y equals that, it would be really close to sine x as long as you're close to pi over 3. That's the idea. And so, so tonight, they'll get a little harder with the derivatives because you've got some more time, and I was trying to make sure we got done in class, and you should be okay. Next time we're going to start talking about the error of a Taylor polynomial, and if you look ahead, then you're going to see that formula, which is going to freak out a little bit maybe, but once I explain it to you, I hope that we can do a good job of having it make sense. So that's coming next time. And that, I'll let you know, like that was the thing that scared me most about teaching this class, was this formula right here. Like I knew it was a thing. I didn't remember it from 1984. No. But I just looked at that and I was like, what the heck is that? And I hope I'll be able to break it down for you and make it very clear, because now I get it, but when I first was teaching the class, I didn't. Okay, hope you have a great weekend, and remember the quiz is really low key on Monday, and that's it. So take care, and we'll see you soon. Bye, everybody.